Welcome to the digital learning platform of Sri Guru Sudhendra College, Bachelor of Computer Application BCA, subject microprocessor BCA 4th semester. So in this video, we'll discuss about stack operations and instructions. I'm very sure your focus is on the middle picture than the right and left one. Yeah, fine. So the person is sitting here with, it's a time to enjoy something. I'm very sure he has got three options here, either to read a book or to go through the entertainment or to have something. So whichever order you want, you can follow. So here, let me that too after this video session. But here before that, we'll go through the contents, or we'll understand the procedure in which it functions. So if this person want to enjoy the Kerala parota, so which parota has to be handpicked? If it is something a magic or a circus, whichever the person want, he can. But here we are following a systematic contiguous application methods. So the normal function is, out of these Kerala parota, this person has to pick this top one. Fine. Now after having food, what next? The person is going to handpick the book. So out of all those textbook notes available here, again the same rule applies here. The person is going to handpick this, the top one, once the study is done. Normally, right? So to take a rest, to enjoy a particular time, the person is going through the entertainment. So there are number of CDs available, and out of this boy is going to select this CD. Now what is happening here? There are bunches of the set of parotas which are waiting, set of books are available, number of CDs are available, but why only these three will get the priority? Why not others? Right? So this method we call it as stack applications. There are set of contents here in all the three pictures, but while selecting or while putting something more, what we do is we are going to identify the top. So here we give the importance to the top, top and top. So this concept is called stack. Let us understand this through the programming application. So here there is a memory location where we are memory which is available, where we are going to keep the data. So this arrangement here we are considering it as stack. Why the word stack has come here? Because it follows a method called LIFO, last in first out, last in first out. Always the insertion and deletion, it happens from an end called top. What we are doing here, this is the stack. We are storing the elements, and this storing the element we call it as push operation. Push operation is nothing but putting the data element. Now what is a pop operation? Pop operation is nothing but removing the data from the stack is called pop operation. This is push operation and this is pop operation. Push, pop. So this itself is a LIFO, last in first out application. So here you should remember what stack is all about, what is the importance of the top, and along with that how push functions. Push is used to store, pop is used to remove the element, and LIFO is a technique through which this entire system functions. There is another picture, because whatever we do here, for that we go through the programming application. Push is a function which is going to insert the number, pop is a function which is going to remove the number, and top always it is going to point the topmost element present in this given list. This entire list we call it as stack. So here you should remember top, push and pop. But when you talk about programming, in programming what we do is we consider the stack, the portion of RAM itself. What you can do, you can call it as stack, because here already you have witnessed it has got set of memory locations which are continuous. Here at least this picture it shows there are set of continuous memory location here, 1 2 3, right? So considering this continuous memory locations, what we do, anyhow RAM has got set of memory locations which are very continuous. So a portion of RAM is considered as stack here. Fine. Now for example, F000 is the beginning of the stack and consider FF is the end of the stack. Here what we are doing, we are mentioning this is the top of the stack. The top of the stack, we are considering it as SP, right? SP is a stack pointer. This particular stack pointer is pointing the top of stack. This is the programming method. So the way we understand the real life applications and programming, we have to link it, right? So initially we started discussion with the real life example, then we switched over to the technique, then finally to the programming, now to the core concept. What we are doing, we have to consider the memory structure in which we should know the base and the end location, and the stack pointer represented as SP, which is going to point the top of the stack. Here we should understand the four specific instructions. The first and foremost, it is SPHL. SPHL is a stack instruction. So what is SPHL here? SPHL stands for copy the content of HL registers to the stack pointer. SPHL means copy the content of HL register to the stack pointer. Already in this previous slide we have discussed SP stands for the stack pointer, which is mentioning the top of the stack. Now at the same time, here we are considering HL. Why HL itself we are focusing here? HL register is a register which is directly linked to memory, right? And already here we are considering a memory, the RAM. So considering these factors, for stack application, what we do, as we are using memory here, we prefer HL register. SPHL, it stands for copy the content of HL register to the stack pointer. The second instruction is XTHL. The second instruction is XTHL. Exchange the content of H and L with top of the stack. Exchange the content. Once again, in this instruction, we are using HL register. Exchange the content of HL register with top of stack. With top of stack. XTHL. X stands for exchange the content of HL register with top of stack. So top of the stack and HL register content, if you want to exchange, then this instruction to be used. Last two instruction, push and pop. Now what is push? Push is an instruction which is used to store the value to the stack. Push register pair. What happens here? Example, push B. It means push the content of BC register. In case if you are using DE register, we are going to mention only D, push D, right? So here what we are doing, push the content of register pair. Whatever the content we have in the register pair, it goes to the top of stack. Because the stack pointer is pointing to the top of stack, so as and when you write push register pair, the content of register pair, it goes to the top of stack. If you want to remove the content from top of the stack, you should use an instruction called pop register pair. Pop register pair, it means remove the content, right? Take the content out of the stack. Where to store? Once you take the content has to be stored in some location. Which location? To the register pair. Pop the content. Pop the content and store it in register pair is pop. Push register pair means store the content which is there in register pair to the top of stack. See the four instructions which are very much essential. SPHL. Copy the content of HL register to the stack pointer. Exchange the content of HL register to the top of the stack. And the third one, push the register pair. Pop register pair. Fine. So this is about the basics of stack. Here you should understand what stack is all about. What do you mean by the application of stack? Why stack is actually used? How stack functions? What are the various instructions are used in stack? Let us go through few more concepts, the sub concepts through question and answer. On screen you have two questions here. What is stack? And the second one is what is subroutine? So these are the answers for you. Whatever we have discussed, the same contents. You can just pause the video and you can go through the things in detail. The definition of stack and the definition of subroutine. Then the three more things. How beginning of the stack is defined. How the beginning of the stack is defined. See the answer is mentioned here. Beginning of the stack is mentioned by using LXI-SP. Right? Load immediately the content through the stack pointer. How can a subroutine be implemented, how subroutine can be implemented, and what is RST instruction used for, why this RST instruction is used in applications. All this here both the concepts we have concepts from stack as well as we have concept from subroutine. Then the last two questions. When subroutine is called, where the address of the instruction following the call instruction stored. See, this is the actual application of stack. From main function, what we do, we jump to the subroutine. From main function, what we do, we are going to jump into the subroutine. Once the subroutine entire function done, what we do, we come back to the main function. So during that particular process, the instructions, the address is stored in a location. That location we call it as stack. And the last instruction, last question, when pop h instruction is executed, where the 2 data bytes at top of the stack are transferred. When you are using a pop h instruction, right? Pop h, what do you mean by pop h? Pop h means pop the content from stack. After taking the content out of the stack, where you are going to store, either you can store it in D register, or you can store it in BC register, or you can store it in accumulator, or you can store it in HL register. So here already we have mentioned H, it means we are storing the content in HL register. So this is about stack operations and various stack instructions used in microprocessor. Good time, take care.